Imagine building something so massive that no plane on Earth can carry it whole. So heavy that a single wrong move could destroy 40 million euros in seconds. And so complex that it takes ships, rivers, midnight highways, and a whale-shaped aircraft just to bring its pieces together. This is not fiction. This is the real story of how Airbus builds the world's biggest passenger jet, the A380, and the impossible journey its parts take before they ever become a flying machine. If you have ever sat in an airplane and wondered how something this huge even gets made, you are about to find out just how insane the answer really is.
Airbus is not a single factory sitting in one country. It is a European dream, stitched together from 4 nations that once decided to challenge the biggest name in aviation, Boeing. Back in the 1960s, France, Germany, Spain, and the United Kingdom joined forces with one bold ambition: to build commercial aircraft that could compete on the world stage. But there was a problem baked into this partnership from day one. Airbus ended up with 11 production sites scattered across different countries, each one specializing in a different part of the plane. This was not a flaw. It was a deliberate design, but it created a logistical puzzle unlike anything the aviation world had seen before. Each Airbus factory became a master of one specific piece of the puzzle. In Hamburg, Germany, workers build the tail sections with incredible precision. In Saint-Nazaire, France, teams construct the central fuselage and the nose. Over in Broughton, England, engineers craft the wings, arguably the most delicate and important part of any aircraft. And in Cadiz, Spain, another team builds different tail components entirely. 4 countries, 4 specialties, and one shared goal: to eventually bring every single piece together in one place and turn them into a complete flying aircraft ready for the skies. That one place is Toulouse, France, home to Airbus's main assembly line, where thousands of workers wait for parts the size of football fields to arrive. In the early days, when demand for Airbus planes was still low, the company relied on regular trucks and cargo ships to move these giant components. It worked, but it was painfully slow. Parts could take months to travel from one factory to another, and in a business where speed determines survival, months of waiting were simply unacceptable. As demand grew and orders piled up, Airbus realized this old method was quietly strangling its own growth. The company needed something built specifically for this challenge, and the answer came from an unexpected place: nature itself. In the freezing waters of the Arctic Ocean lives a whale known for producing hauntingly beautiful sounds, almost like a song drifting through the ocean. Airbus looked at this creature's shape and saw something remarkable: a design perfectly suited for carrying enormous cargo. In 1994, inspired by this very whale, Airbus unveiled a new aircraft built for one single purpose: transporting the massive and impossibly heavy sections of its planes. They named it Beluga, and it would change everything. The Beluga is not just big, it is almost unbelievable in scale. Stretching 56 meters, or 184 feet, it is longer than an Olympic swimming pool from end to end. Standing 17 meters tall, roughly 56 feet, it towers like a 7-story building rolled onto a runway. Its cargo hold is so massive that engineers calculated you could fit around 182 small cars inside it. But the true genius lies in its nose, which lifts upward like the hood of a car, allowing enormous aircraft parts to be loaded and unloaded with surprising ease and speed. Picture this. A single pair of wings for an Airbus A350 measures 32 meters long and costs around 40 million euros, close to 400 crore rupees. That single wing pair now slides smoothly into the Beluga's belly. Something that used to demand weeks of careful shipping now happens in a fraction of the time with far less risk. What once took cargo ships and trucks several months to deliver, the Beluga now completes in just 2 hours, flying directly from one European site to another. This single innovation kept Airbus's daily production of 3 aircraft moving without disastrous delays, and it proved that solving a transport nightmare could unlock an entire industry's growth. Encouraged by the Beluga's success, Airbus went further in 2014 and introduced an upgraded version called the Beluga XL, designed to carry even bigger loads and more complex components. For a while, everything seemed perfectly solved. Airbus had built its own flying solution to an impossible transport problem, and production kept accelerating year after year. But then, in the year 2004, Airbus unveiled something so massive it broke the very system that had just been perfected. The Airbus A380, the largest passenger aircraft ever built. And suddenly, the Beluga's incredible abilities were no longer enough to handle what was coming. The A380 was a different beast entirely. Its fuselage stood 8.4 meters tall, and near the fuselage, its wingspan reached 16 meters wide, dimensions that dwarfed anything the Beluga had carried before. The math simply did not work. The Beluga XL's cargo compartment height topped out at 7.5 meters, meaning neither the A380's fuselage nor its colossal wings could physically fit inside. To make matters more complicated, while a cylindrical fuselage can be... The reason behind this comes down to raw engineering necessity. Wings house the fuel tanks and the hydraulic systems that keep an aircraft alive in the sky, and they endure more structural stress than almost any other part of the plane. Building them in one continuous piece eliminates weak points and prevents dangerous fuel leaks that could occur at any seam or joint. This meant Airbus faced an entirely new transport crisis, one that no flying whale, however brilliant its design, could solve on its own. The sky was no longer the answer, and Airbus had to think completely outside the box. At first, engineers explored building an even bigger aircraft, a so-called Beluga XXL, hoping to simply scale up the same solution that had worked before. But the numbers quickly killed that idea. Redesigning the Beluga from scratch and boosting its engine capacity would have cost billions of euros, an investment that made little financial sense. The A380 was so enormous that most airlines could not even operate it efficiently, which meant global demand for the aircraft stayed relatively low. Spending billions to build a bigger plane just to serve a handful of aircraft simply did not add up. So Airbus abandoned the flying solution altogether and turned to something far more unexpected. This is where the story shifts from the sky to the sea and then to the road in what became known as Airbus's Super Convoy, a journey involving oceans, rivers, and highways, all working together like a perfectly choreographed dance. Airbus commissioned specially designed roll-on, roll-off ships, vessels built specifically to carry oversized cargo using wheeled platforms instead of cranes. These ships allowed massive aircraft sections to simply roll directly onto the vessel deck, eliminating the need for lifting equipment entirely and making the loading process dramatically safer for such delicate, priceless cargo. One of these vessels, named City of Hamburg, stretches 126 meters long and 20 meters wide, offering 5 times more cargo space than even the Beluga XL could manage. From the port of Hamburg in Germany, colossal Airbus sections roll straight onto rolling platforms and glide directly into the ship's hold. This ship then embarks on a 1,600-kilometer journey across open water, sailing from Germany all the way to the port of Saint-Nazaire in France, carrying cargo worth hundreds of millions of euros through some of the most unpredictable waters in Europe. This ocean crossing is far from peaceful. The North Sea is notorious for sudden storms and waves that can rise as high as 5 meters, turning a routine shipping route into a genuine test of nerve and precision. If the cargo shifts even slightly during rough seas, a wing worth 400 crore rupees could be damaged beyond repair, forcing Airbus to rebuild it entirely from scratch. Because the stakes are this high, the ship's captain and crew inspect the cargo chains every 4 hours without fail, while a camera monitors the precious cargo around the clock, ensuring not even the smallest risk of damage slips through unnoticed. Once the ship reaches Saint-Nazaire, the journey is far from finished. The massive aircraft parts are carefully unloaded and transferred onto specially engineered barges, vessels built to carry this cargo further inland along the Garonne River toward the city of Bordeaux. It sounds simple enough until you realize the river holds one of the most nerve-wracking obstacles in this entire operation: a centuries-old stone bridge that was never designed with modern aviation in mind, yet somehow still stands directly in the path of Airbus's most valuable cargo. This bridge, known as Pont de Pierre, was constructed all the way back in 1810, and its arches are far from uniform in size. Only one specific arch, numbered 9, offers a width of 19 meters, just barely enough for the barges to squeeze through, leaving mere inches of clearance on either side. Width alone was not the only obstacle Airbus engineers had to conquer, because the height of these arches depends entirely on the river's water level, which shifts constantly and unpredictably depending on forces far beyond human control. Even though this stretch of the Garonne River sits 60 kilometers away from the Atlantic Ocean, its water level still rises and falls with the ocean's tides, an invisible force reaching far inland. Under normal conditions, the water level here stays too high for barges to safely pass beneath the bridge's low arches without risking a catastrophic collision. But nature offers a narrow window of opportunity, a mere 3 minutes every 12 hours, when the tide drops just low enough to let the barges squeeze through safely. And missing this brief moment carries serious consequences for the entire operation. If the captain misses this incredibly narrow window, the entire convoy is forced to wait a full 12 hours before trying again, throwing Airbus's entire production schedule into chaos and delaying an aircraft that customers are anxiously waiting to receive. To solve this precise timing problem, engineers installed adjustable platforms onto the barges themselves, allowing them to lower or raise their profile and pass beneath the bridge safely even during the trickiest low tide conditions. It might sound like a small mechanical fix, but this single innovation carries enormous weight in keeping Airbus's global production moving without disruption.
By this point in the journey, these aircraft parts have already crossed open ocean and navigated a centuries-old river bridge. Yet the story is still not finished, because Bordeaux sits 250 kilometers away from Toulouse, and this final stretch belongs entirely to the road. This is where 50-meter-long super trucks take over, each one powered by a 650-horsepower engine and rolling on 96 wheels, purpose-built to carry Airbus's most delicate cargo across French highways toward the final assembly line waiting in Toulouse.
Moving something this massive through populated areas is nowhere near as simple as it sounds. To avoid daytime traffic and minimize risk, these convoys only move at night, when highways and city streets can be temporarily closed off just for their passage. A dedicated team of around 40 people, including police officers, escort vehicles, and specialized engineers, accompanies every single convoy, working together like a finely tuned unit to guide these oversized loads safely through narrow streets and unpredictable obstacles under the cover of darkness. The most nerve-wracking part of this entire road journey happens in small towns, where narrow roundabouts and tight corners test the convoy's precision to its absolute limit. A single wing can hang up to 15 meters behind the truck, passing dangerously close to lampposts, trees, and rooftops, sometimes with only a few centimeters of clearance separating priceless cargo from permanent disaster. One small miscalculation, one moment of poor judgment, and years of engineering work could be destroyed in an instant, which is exactly why every single movement is planned with military-level precision. When these parts finally arrive at the Toulouse assembly facility, after crossing oceans, squeezing through centuries-old bridges, and navigating narrow midnight roads, the real magic begins. Thanks to highly advanced assembly systems, workers managed to piece together components that traveled thousands of kilometers into a single unified structure within just a matter of hours. The A380, the largest passenger aircraft ever built, requires more than 19,000 rivets just to hold its fuselage together, along with over 4,000 additional rivets used specifically to attach the wings to the main body of the aircraft. After the engines, electronics, interiors, and final paint job are complete, the aircraft is finally ready for delivery to its airline. From the very first moment raw materials begin production, to the incredible transport journey across sea and land, to final assembly, an entire A380 takes approximately 9 months to complete from start to finish. Even after decades of production, only 251 units of this aircraft have ever been built, largely because operating a plane this massive requires resources that most airlines around the world simply cannot justify or afford. Surprisingly, one single airline, Emirates, owns roughly 50% of every A380 ever manufactured, showing just how selective this aircraft's ownership truly is across the entire aviation industry. This massive plane can carry as many as 850 passengers in a single flight, an almost unimaginable number for one aircraft. Its total takeoff weight reaches approximately 575,000 kilograms, roughly equal to the combined weight of 300 SUVs rolling down a highway together, a number that becomes almost impossible to visualize until you picture it firsthand.
When it comes to cost, a single Airbus A380 carries a price tag of around $445 million, translating to roughly 3,800 crore rupees, an amount so massive that you could purchase 5 separate Boeing 737 aircraft for the exact same money. So, the next time you find yourself boarding an Airbus aircraft, take a moment to remember everything that happened long before that plane ever touched the runway. The oceans it crossed, the ancient bridge it barely slipped beneath, and the quiet midnight roads it traveled through, just to reach the sky. Behind every flight is a story of human determination, engineering brilliance, and teamwork stretched across an entire continent, all working together to turn separate pieces of metal into one magnificent machine, capable of carrying hundreds of people safely through the